Good afternoon, sir. I am Rosana Rodriguez, and today I am going to report Chapter 8 that is all about hypothesis testing. So here are the content of Chapter 8, the hypothesis testing, and today my task is to report the 8-1, 8-2, and 8-3. So here are the Chapter 8 objectives. And now let's start in section 8-1. So what is hypothesis? In statistics, a hypothesis is a claim or statement about a property of a population. So hypothesis, paano siya kanang mura siya kanang statement na kanang statement about ang property or ang things. A hypothesis test or test of significance is a standard procedure for testing a claim about the property of a population. So, a hypothesis test, mana na siya nga itong kanang i-test ni mo na nga property or i-test ni mo na yung statement about nga property. Next. Rare event rule for inferential statistics. So, rare event rule, na i-rule jud inferential statistics. If, under a given assumption, the probability of a particular observation event is exceptionally small, we conclude that the assumption is probably not correct. So, manay rule sa rare event rule for inferential statistics. So, example. So, mana siya ang example. About ni siya sa kanang gender choice. Gender choice, which according to advertising claims allowed couples to increase their chances of having a boy up to 85%, a girl up to 80%. So gender choice, either pila ka percent ang boy is up to 85% ang chances nga magkaanak ang boy, then a girl up to 80% niya chances to have a girl. Gender choice was available in blue packages for couples wanting a baby boy, and pink packages for couples wanting a baby girl. Suppose we conduct an experiment with 100 couples who want to have baby girls, and they all follow the gender choice easy to use in home system described in the pink package. For the purpose of testing the claim of an increased likelihood for girls, we will assume that gender choice has no effect. Using common sense and no formal statistical methods, what should we conclude about the assumption of no effect from gender choice if 100 couples using gender choice have 100 babies consisting of 52 girls and 97 girls? So karon ato ang what should we conclude about the assumption of no effect from gender choice if 100 couples using gender choice have 100 babies consisting of 52 girls and 97 boys? So, we're here the explanation for example A. We normally expect around 50 girls in 100 births. The result of 52 girls is close to 50, so we should not conclude that the gender choice product is effective. So, if the 100 couples use no special method of gender selection, the result of 52 girls method of a gender selection, the result of 52 girls could easily occur by chance. The assumption of no effect from gender choice appears to be correct. There isn't sufficient evidence to say that gender choice is effective. So, wala dyan ka na sufficient evidence na ang gender choice is effective kung what if want ni mo nga magka-baby o girls, want ni mo nga magka-baby o boy. Next is the result of 97 girls in 100 births is extremely unlikely to occur by chance. We could explain the occurrence of 97 girls in one of two ways. Either an extremely rare event has occurred by chance or gender choice is effective. The extremely low probability of getting 97 girls is strong evidence against the assumption that gender choice has no effect. It does appear to be effective. Now we next is now we discuss about basic of hypothesis testing. So here are the key concepts. So here are the objectives of section 8-2. Given a claim identify the null hypothesis and the alternative hypothesis and express them both in symbolic form. Given a claim and sample data, calculate the value of the test statistic. Given a significance level, identify the critical values. Given a value of the test statistics, identify the p-value. State the conclusion of a hypothesis test in simple non-technical terms. So here are the example. Let's again refer to the gender choice of atong example ganyan ato tong basihan. So one discernible of Procare Industries. Procare Industries claim that couples using the pink packages of gender choice would have girls at the rate that is greater than 50% or 0.50. Let's again consider the experiment whereby 100 couples use gender choice in an attempt to have a baby girl. Let's assume that the 100 babies include exactly 52 girls, and let's formalize some of the analysis. Under normal circumstances, the proportion of girls is 0.50. So, a claim that gender choice is effective can be expressed as P greater than 0.5. Using a normal distribution as approximation to the binomial distribution, we find P times the 52 or more girls in 100 births equal 0.3821. So, here are the figure 8-1. Makita na to ang mga kanino. Reasonable explanation, we conclude that the proportion of girls born to couples using gender choice is not significantly greater than the number that we would expect by random chances. Observations. So, this observation, we know later the explanation of it, how the claim of, yun sa napag-claim ang mga statement, yung mga explanation, so, silbi na siya ng mga examples, no? Next is, So here are the components of a formal hypothesis test. So in the components of formal hypothesis test, there consume of two types, null hypothesis and statistical hypothesis. So first is the null hypothesis. So ang symbol sa null hypothesis is H sub 0 or 0 is a statement that the value of a population parameter such as proportion, mean, or standard deviation is equal to some claimed value. We test the null hypothesis directly, either reject null hypothesis or fail to reject. So, di na ito mahibawaan ko, i-reject ba na siya, kung ato ba i-reject ang null hypothesis or either or fail to reject. Next. So here are the the components of two hypotheses. The formal hypothesis test is null hypothesis and alternative hypothesis. So the second is alternative hypothesis. So ang alternative hypothesis is denoted by H sub 1 or H sub A. It is the statement that parameter has a value that somehow differs from the null hypothesis. The symbolic form of the alternative hypothesis must use one of these. So, kaninga mga symbols not equal, greater than, or less than. So, note about identifying null hypothesis and alternative hypothesis. So, ni atong notes na para ma-identify na to sa ang So, identify the specific claim of our hypothesis to be tested and expressed in symbolic form. Give the symbolic form that must be true when the original claim is false. Of the two symbolic expressions obtained so far, let the alternative hypothesis H sub 1 be the one not containing equality, so that H sub 1 uses the symbolic less than or greater than or not equal. Let the null hypothesis be the symbolic expression that the parameter equals to the fixed value being considered. So, man atong mga notes about identifying null hypothesis and alternative hypothesis. So, next. Example, identify the null and alternative hypothesis. So, itong pagitaon, yung mga example na itong pagitan ang null and alternative hypothesis itong i-refer sa figure 8-2. So, first, the proportion of drivers who admit to running with lights is greater than 0.5. So, here, we can see that the proportion of drivers who admit to running with lights is greater than 0.5. So, in step 1 of figure 8-2, we express the given claim. So, ito i-follow na ito nga steps itong nasa figure 8-2. Kanina step nga, first, identify the specific claim or hypothesis. So, itong i-identify. So, we express the given claim as P greater than 0.5. In step 2, we see that if P is greater than 0.5, if P greater than 0.5 is false, then P not less than 0.5 must be true. In step 3, we see that the expression P greater than 0.5 does not contain equality. So let the alternative hypothesis be P greater than 0.5 and will let alternative the null hypothesis be P equal 0.5. So, na to siya nung itong nakita ang yun. Ato lang i-follow tong steps na nasa figure 8-2. So, next example is the mean height of professional basketball. Players is at most 7 feet in September 1 of figure 8-2. So, in step 1 September. So, we express a mean of at most 7 feet in symbols as mu not less than 7. In September 2, we see that if mu not less than 7 is false, then mu is greater than 7 must be true. So in step 3, we see that the expression mu is greater than 7 does not contain equality. So we'll let the alternative hypothesis H sub 1 be mu greater than 7 and we'll let null hypothesis be mu equals 7. Next example. The standard deviation of IQ scores of actors is equal to 15. So step 1, we express the given claim as standard deviation equals 15. So in step 2, we see that if standard deviation is equal to 15 is false, then standard deviation is not equal to 15 must be true. So step 3 will let the alternative hypothesis H sub 1 be standard deviation is not equal to 15 and will let null hypothesis be not equal to 15. Standard deviation is not equal to standard deviation. So sa null hypothesis gilit na tong standard deviation equal to 15 but in alternative not equal to 15. So gabali-bali ko ano siya no. Next is what is test statistics. It is a value using in making a decision about the null hypothesis and is found by converting the sample statistics to a score with the assumption that the null hypothesis is true. So, test statistics. So, what is the test statistic? Test statistic and is found by. So, wala siya no kanang is a value used in making a decision. So, kanang diha ka kanang bitong making a decision about the null hypothesis din. and found by converting the sample statistics to a score with the assumption that the null hypothesis is true. So here are the formulas of test statistics. Test statistics for proportion and test statistics for proportions, and test statistic for mean, and test statistic for standard deviation. So, makita na to ang formula diha sa mga test statistics. Next is example. A survey of n equals 880 randomly selected adult drivers showed that 56% or p equals 0.56 of those respondents admitted to running red lights. Find the value of the test statistics for the claim that the majority of all adult drivers admit to running red lights. We will see that there are assumptions that must be verified. For this example, assume that the required assumptions that are satisfied and focused on finding the indicated test statistics. Solution. So here are the solution na atong gamiton nga formula is katong formula sa test statistics for proportions. Muna siya atong gamiton nga for formula. So ato lang siyang ipang substitute. Ang 0.56 is that mauna siya ang katong mauna siya ang mga respondents of 56% of the respondents. Then ang 0.5 is the preceding example showed that the given claim results in the following null and alternative hypothesis. Null hypothesis p equals 0.5 and p greater than and the alternative hypothesis p greater than 0.5. Because we work under the assumption that the null hypothesis is true with p equals 0.5, we get the following test statistics. So wala na siya, ato lang ipang substitute asa siya dapat ibutang sa mga value niya, then makuha na nato kung kanang ang ipangitaan ni nga problem. Find the value of the test statistics for the claim that majority of all adult drivers. So next, we know from previous chapter that a z-score of 3.56 is exceptionally large. It appears that in addition to being more than half, the sample result of 56% significantly more than 50%. So next is, now we will discuss the critical region, critical value test statistics. So money siya ang proportion for adult drivers, the rating that they run red lights, sample proportion of here usually high sample proportion critical region area. So ato maning na kung ano kanang katong mag-find tag z-score, then ato siya himuan og silbi mo critical z is the critical value. I-find na to ang area using the standard deviations anana. So makita na learn na to na before the topic. So what is critical region? The critical region is the set of all values of the test statistics that cause us to reject the null hypothesis. For example, see the shaded region in the previous video. So ang critical region mo na siya ang mga values sa test statistics nga mo hinungdan nga ma-reject na to ang null hypothesis. So makita na to na sa figure. So next is, what is significance level? Denoted by A, alpha, is this probability that the test will fall in critical region when the null hypothesis is actually true. This is the same introduced in section 7-2 common choices for are common choice significance level are 0.05, 0.01, and 0.10. Next is what is critical value. So critical value is any value that separates the critical region where we reject the null hypothesis from the values of the test statistic that do not lead to rejection of the null hypothesis. The critical values depends on the nature of the null hypothesis, the sampling distribution that applies, and the significance level. See the previous figure where the critical value of z is equal to 1.645 corresponds to a significance level of alpha equals 0.05. Next is two-tailed, right-tailed, and left-tailed test. So, what is tails? Tails in a distribution are the extreme regions bounded by critical values. So, muna siya ang tails. So, when we say two-tailed test, makita natin dito sa figure, it is the alpha is divided equally between the two tails of the critical region. So, sa both side, makita na ito nga na siya murag ka ng sa figure na left and right both reject ang null hypothesis, but in the center is failed to reject the null hypothesis. So, mo na siya two-tailed test. No, kanang naa siya kanang duha na nasa kilid, both left and right sa figure. Makikita natin dyan sa figure. So, both reject the null hypothesis. So, mo na siya ang gitawag og two-tailed test. Next is the right-tailed test. So, here, the null hypothesis is equal and the alternative hypothesis is greater than. So, points right. So, if the null hypothesis is equal and the alternative is greater than, so the points is right. So, here, i-reject niya ang null hypothesis, but sa pika side is failed to reject the hypothesis. Mo nang gitawag siya og kanang right-tailed test. Dili makita na to sa ang gamit nga sign is greater than. Kaya siya. Next is the left-tailed test. So, more baliktad lang siya, no? So, if null hypothesis is equal, then ang alternative hypothesis is less than, so the points is left. So, timan-an na nato ang sign bitaw kung ang sign is less than, then greater than, na equal. Atong kanang, kung ma-find lang nato kung you're failed to reject ba siya, then ang mga signs, may baon nato kung isa siya nga test, left-tailed test ba siya, right-tailed test ba siya. So, mano siya, no? The left-tailed test. Next is p-value. What is p-value? P-value is the probability of getting a value of the test statistic that is at least as extreme as the one representing the sample data. Assuming that the null hypothesis is true, the null hypothesis is rejected if the p-value is very small, such as 0.05 or less. So, dili, ang p-value is nag-represent siya example data na assuming that null hypothesis is true. Pero the null hypothesis is rejected, ma-reject ang null hypothesis if ang p-value nimo is gamay lang siya. So, less than 0.05. So, ubos pa sa 0.05. So, na ang p-value, probability value. Next is, so here are the conclusions in hypothesis testing. We always test that the null hypothesis. The initial conclusion will always be one of the thing. Reject the null hypothesis or fail to reject the null hypothesis. So, moro dyan natong giman when testing the null hypothesis, either gi-reject ba ang null hypothesis or failed to reject the null hypothesis. So, need dyan nato ka nang i-find ang mga steps. Ito dyan surion ang mga problem na iyan yatubang ang magamit na ito atong pagka-experiment. Decision criterion, traditional method. Reject null hypothesis if test statistics fall within the critical region. Fail to reject null hypothesis if the test statistic does not fall within the critical region. So, mara na itong timan sa null hypothesis if fail to reject or gina-reject nimo ang null hypothesis. Next, P-value method. Reject null hypothesis if the p-value is not less than alpha, where A is the significance rate such as 0.05. Fail to reject if the p-value is greater than alpha. So for some clarification that I know, so ang kana siyang sign is less than or equal. Mara na siyang so sorry for the wrong So reject null hypothesis if the p-value or probability value is less than or equal to A, such as 0.05. Fail to reject null hypothesis if the p-value is greater than alpha or the value. Next is another option. Instead of using a significant level such as 0.05, I simply identify the probability value and left the decision to the reader. So kuan lang siya no easy if kanang instead nga mo gamit tag significance level such as 0.05, ato lang i-identify ang p-value and the reader na mo judge if mo decision about the value, about the p-value. Because a confidence interval estimate of a population parameter contains the likely values of the parameter, reject a claim that the population parameter has a value that is not included in the confidence interval. So procedure for finding probability values. So let's start. What type of test? So ato lang if it is a left-tailed or right-tailed test. So if both sides na asa left and tail, so that is called two-tailed test. So the right and left. So two-tailed test is the test statistics for the right to the right or left of center. Is the test. So left. So here the figure. P-value equals twice, so in the left side, p-value equals twice the area to the left of the test statistics, and p-value equals area to the left of the test statistics. So siya is twice this area, twice. Kita na to. And in the right is p-value equals twice the area to the right of the test statistics, and p-value area to the right of the test statistics. Of the test statistic, then p-value is twice this area. Kung matawag na to siya o ganang two-tailed test, so mato siya ang procedure to find p-values. Finding the p-values, first determine the given conditions result in a right-tailed test, a left-tailed test, or a two-tailed test, then find the p-values and state and conclusion about the null hypothesis. So, ano siya nga example? Ano ko na itong pangitaan, no? So, with a claim of p greater than 0.25, the test is right-tailed. Because the test is right-tailed, because the type figure shows that the p-value is the area to the right of the test statistics, z equals 1.18. We refer to A-2. So, na makita na to na sa book na mga table dito nga makita na to ang mga na A-2 table, na po Z table, na po T table. And find that the area to the right of z equals 1.18 is 0.1190. The p-value of 0.1190 is greater than the significance level of equals 0.05, so we fail to reject the null hypothesis. The p-value of the 0.1190 is relatively large, indicating that the sample results could easily occur by chance. So, ano siya ang solution sa example A. Next is the second example, which the claim of p is not equal to 0.25. So the test is two-tailed. So two-tailed cannot equal na siya. Because the test is two-tailed and because the test statistic of z equals 2.34. So at the right of the center, so p-value is twice the area of the right of z equals 2.34. We refer to table A-2 and find the area to the right. So to the right, of z equals 2.34. So in finding so we find that z equals 2.34 of is 0.0096. So the probability value is 2 times the 0.0096 equals 0.0192. The probability value of 0.0192 is less than or equal to the significance level, so reject the null hypothesis. So, kung man siya kanang less than or equal, so we reject the null hypothesis. The small probability value 0.0192 shows that the sample results are not likely to occur by chance. So, ibigay siya no, but kung astong sabton ang mga steps in getting of it is matong kuan dyan nato makuha nato dayon ang point. So, wording of final conclusion. So, mali siyang conclusions. Does the original claim contain the condition of equality? Yeah, if yes, original claim contains equality. So, common here is the wording of final conclusion about what I have discussed before about the reject and fail to reject null hypothesis. Wording of final conclusions, hypothesis. So, na siya nun ang wording of final conclusions. Next, accept versus fail to reject. So, some texts use accept the null hypothesis. We are not proving the null hypothesis. The sample evidence is not strong enough to warrant rejection, such as not enough evidence to convict a suspect. So now let's discuss the type 1 error. So what is type 1 error? Type 1 error is the mistake of rejecting the null hypothesis when it is true. So kanang type 1 error is kanang mistake of rejecting the null hypothesis when it is true. Kanang wala niya i-reject ang null hypothesis even in it is true. The symbol alpha is used to represent the probability of a type 1 error. Manigang alpha to represent the type 1 error. Alpha. Next is what is type 2 error. A type 2 error is the mistake of failing to reject the null hypothesis when it is false. The symbol beta is used to represent the probability of a type 2 error. So, ang type 2 error is kanang mistake of failing to reject. So, kanang mistake of failing to reject the null hypothesis when it is false. So, sa false na mistake siya na wala niya i-reject if it is false. So, to represent the probability of a type 2 error is the symbol beta. So, assume that we conducting a hypothesis test of the claim P greater than 0.5. Here are the null and alternative hypotheses. So, the null hypothesis P equals 0.5 and the alternative hypothesis is P greater than 0.5. So, identify a type 1 error and identify the type 2 error. We identify. So, first is we need to identify the type 1 error. Type 1 error is the mistake of rejecting a true null hypothesis. So, this is a type 1 error. Conclude that there is sufficient evidence to support that P is greater than 0.5 when in reality is P equals to 0.5. Next is, a type 2 error is the mistake of failing to reject the null hypothesis when it is false. So, this is a type error because it is failed to reject that P is equal to 0.5 and therefore fail to support P greater than 0.5 when in reality is P is greater than 0.5. Victory function. No? Then, so here are the type 1 and type 2 errors. We decide to reject the null hypothesis. We fail to reject the null hypothesis. So, true state of nature, the null hypothesis is true. The null hypothesis is false. So, type 1 error, rejecting a true null hypothesis, correct decision. So, ano siya on the table. So, type 1 and type 2 errors. Controlling type 1 and type 2 error. For any fixed alpha and increase in the sample size n will cause a decrease in beta. For any fixed sample size n, a decrease in alpha will cause an increase in beta. So remember, ang alpha is type 1 error and the B is representing type 2 errors. Conversely, an increase in type 1 error will cause a decrease in type 2 errors. To decrease both type 1 error and type 2 error, increase the sample size. Definition. So the power of a hypothesis test is probability 1 minus beta of rejecting a false hypothesis, which is computed by using a particular significance level, alpha or type 1 error, and a particular value of the population parameter that is an alternative to the value assumed true in the null hypothesis. That is, the power of the hypothesis test is the probability of supporting an alternative hypothesis that is true. Next. So here are the comprehensive hypothesis test p-value method. So in short, this is a summary. Identify the specific claim or hypothesis to be tested and put it in a symbolic form. Give the symbolic form that must be true when the original claim is false. Of the two symbols expression obtained so far, let the alternative hypothesis be one not containing equality, so that null hypothesis uses the symbol greater than or less than or not equal. Let the null hypothesis be the symbolic expression that the parameter equals the fixed value being considered. Select the significance level based on the seriousness of a type 1 error. Make a small if. The consequences of rejecting a true null hypothesis are severe. Values of 0.05 and 0.01 are very common. Identify the statistics that is relevant to this test and determine its sampling distribution, such as normal, t-square. Find the test statistics and find the p-value. Draw a graph and show the test statistics and p-value. Reject null hypothesis if the p-value is less than or equal to the significance level, alpha. Fail to reject null hypothesis if the p-value is greater than alpha. Restate this previous decision in simple, non-technical terms and address the original claim. Next is the comprehensive hypothesis test traditional method. Same as the comprehensive hypothesis test p-value. So, a confidence interval estimate of a population parameter contains the likely values of the parameter. We should therefore reject a claim that the population parameter has a value that is not included in the confidence interval. In some cases, a conclusion based on a confidence interval may be different from a conclusion based on a hypothesis test. See the comments in the individual sections. So those are the content of 8-2. In the selection, we have discussed the null and alternative hypotheses, test statistics, significance levels, p-values, decision criteria, type 1 and 2 errors, power of hypothesis test. Next is section 8-3, testing a claim about a proportion. So this section presents complete procedures for testing a hypothesis or claim made about a population proportion Proportion. This section uses the components introduced in the previous section for the p-value method, the traditional method, or the use of confidence intervals. So, requirements for testing claims about a population proportion. First, the sample observations are a simple random sample. The conditions for a binomial distribution are satisfied. The conditions greater than or equal 5 and NQ greater than or equal 5 are satisfied, so the binomial distribution of sample proportions can be approximated by a normal distribution with nu equals NP and standard deviation equals square root of NPQ. So here are the notation. N stands for the number of trials. P equal X, N is the sample proportion, P population proportion used in the null hypothesis, and Q is equal to 1 minus P. Test statistics for testing a claim about a proportion. So here is the formula for the test statistics for a claim about a proportion. Next is p-value method. An article distributed by the Associated Press included these results from a nationwide survey of 880 randomly selected drivers. 56% admitted that they run red lights. The claim is that the majority of all Americans run red lights. That is P greater than 0.5. The sample data are N equals 880 and P is equal to 0.56. NP is equal to 880 times 0.5 equals 450 less than or equal 5. And NQ is equal to 880 times 0.5 equals 450 less than or equal 5. Next is an article distributed by the Associated Press included this result from a nationwide survey. Of 880 randomly selected drivers, 56% admitted that they run red lights. The claim is that the majority of all Americans run red lights, that is P less than 0.5. The sample data are N equals 880 and equals 0.56. We will use the p-value method. So here are the solutions. As you can see, the figure or substitute the value. Next is another example. An article distributed by the Associated Press included this result from a nationwide survey of 880 randomly selected drivers. So the claim is that the majority of all Americans red lights, that is P less than 0.5. The sample data are N equals 880 and equals 0.50. So we'll use the p-value method. So here are the solutions. Next is, so we have the graph. An article distributed by the Associated Press included this result from a nationwide survey. So we will use the p-value method, the null hypothesis and alternative hypothesis, and alpha equals 0.05. And the null hypothesis is P equals 0.5 and the alternative hypothesis is equal to P less than 0.5. Another example. Caution: when testing claims about a population proportion, the traditional method and the p-value method are equivalent and will yield the same result since they use the same standard deviation based on the claimed proportion. However, the confidence interval uses an estimated standard deviation based upon the sample proportion. Consequently, it is possible that the traditional and p-value methods may yield a different conclusion than than the confidence interval method. A good strategy is to use a confidence interval to estimate a population proportion, but use the p-value or traditional method for testing a hypothesis. Obtaining a sample proportion. Sample proportion sometimes is given directly. 10% of the observed sports car are red, is expressed as sample proportion equals to 0.10. Sometimes sample proportion must be calculated. 96% surveyed households have cable TV and 54 do not. Is calculated using sample proportion equals x over n equals 96 over 96 plus 54 is equal to 0.64. So x is is the 96 who surveyed household who have a cable TV, and the 54 is a household who do not have a household cable TV. When Gregory Mendel conducted his famous hybridization experiments with peas, one such experiment resulted in offspring consisting of 428 peas with the green pods and 152 peas with yellow pods. According to Mendel's theory, 1/4 of the offspring peas should have yellow pods. Using a 0.05 significance level with the p-value method to test the claim that the proportion of peas with yellow pods is equal to 1/4. We note that n is equal to 428 plus 152 equals to 580. So the sample proportion is 0.262 and p is equal to 0.25. So another example. So here are another ways of computing the examples of Gregory-Mendel, which is the null hypothesis is p equals 0.25 and the alternative hypothesis is p not equal to 0.25 and the n is equal to 580. So in the formula, we need to substitute the value of each variable, and since this is a two-tailed test, the p-value is twice the area to the right of the test statistic using the table A-2. Z is equal to 0.67 is 1 minus 0.07 for 7,486 equals to 0.2514. The next example is when Gregory Mendel, one such experiment resulted in offspring consisting of 420 peas with green pods and 152 peas. Substitute the value of each variable, which is the p-value is 2 times 0.2514 equals 0.5028. We fail to reject the null hypothesis. There is not sufficient evidence to warrant rejection of the claim that 1/4 of the peas have yellow pods. So here are the recap. In this section, we have discussed the test statistics for claims about a proportion, p-value method, confidence interval method, and obtaining sample proportion. So, kani siya nga symbol is what we call the sample proportion, denoted as sample proportion. That's all, and thank you.